So sensitivity analysis should be done of this global leader limit. Let's say range is n by 2 to 2n. N by 2 here, 50 upon 10, it means 25 to 2 into 50, it means 100, 25 to 100. Okay. Here the locality limit is fixed, d into n. D is the dimension of the problem. In our case, the dimension in our example, the dimension is 2. Okay. So d is the 2 into 50 equals to 100. The locality limit should be 100. PR is the perturbation rate, 0.1, 2.9. It should be linearly increasing or maybe a constant. It depends. It's all depends on your problem size. All depends on your problem size. Okay. So a worked example, it's minimization fx equals to x1 square plus x2 square. It's actually shown here. I will discuss it later on. First, I am discussing that why the SMO works. Why the SMO works? So the exploration and exploitation are the two major components of any swarm intelligence-based algorithms, and SMO statistically depicts the balance between them. Okay, how? As the local interface, that is explore the search space, as the global interface exploit. Okay, we can say the global leader and local leader both are explore and exploit. Both perform exploration and exploitation, and the local leader, in case of local leader, the members search in their vicinity, while in the case of global leader, the members explore the search area directed by the global leader. Okay. In the local leader learning phase and global leader learning phase, we select the leaders and we check here where the search process is stagnated or not. We check here the search space is stagnated or not. And if there is a stagnation, in that case, in the local leader decision phase, we introduce some fluctuation. Okay, we randomly initialize the individuals of that particular group. And in the last phase, the global leader decision phase, we divide the population into the subgroups. That also help in the exploration. Okay, how SMO is different? Initially, there is a single group, so every newly generated food source is attracted towards the best food source. We can say the global leader. Okay, so it basically enhances the converging speed of the algorithm. Okay, the solutions converge faster to the global optima. But as a result of such exploitative tendency, in many cases, the population may skip the global minima and can get stuck into local minima. So therefore, to avoid this situation, if the global minima is not updating itself for a predefined number of times, then the group is divided into subgroups. Basically, this is the fusion. Now we are implementing the fusion social behavior, and this is the unique feature of spider monkey optimization as compared to the other swarm intelligence based algorithms. Okay, so now I think we with the queries, if any. Anyone?
The participants are invited for the query. If anyone is having any queries.
Hello.
Yes,
sir. My query is a simple one. I was confused that will these subgroups will search the whole region or a particular region of the search space?
Actually, we are dividing the group into subgroups on the basis of indexes. So here, let's suppose an index is in one group. Now the members search boundary will be limited. Ajay sir, there is some disturbance from your side. Please mute. Okay. So the members now will search in that particular vicinity of that local leader, because you have seen that the step size depends on the two components. One is the difference from the local leader, and another is the vector difference from the individuals of that local group. Okay, so here the search space, the step size should be minimum. So in this way, the exploitation tendency will enhance. Now your question is that it will search the search area nearby. It will search the search area nearby that particular local leader. Okay, nearby that particular. It means we can say that there should be not a very large step size. Is it clear?
So how we will decide that it is large or small?
Actually, one cannot decide that what should be the step size is going on. Okay, because these are the stochastic algorithms. Okay, and stochastic algorithms, it means the step size is basically a combination of a random component and the vector difference between two individuals. Okay, and if the value of random component means random number between 0 to 1. If the value of this random component is less, and if the value of this vector difference is less, then step size should be less. And if value of this random component is high and the vector difference is high, then step size should be high. Okay, so one cannot claim that step size is going to be less or high, but we assume it general tendency that in the in initial iterations, as the individuals exist in distant locations from each other. Okay, so in that case there should be step size, there should be large step size, but in later on when the individuals converge to a particular point, in that case the step size should be less because the vector difference will be very small. Are you getting my point?
Yes, sir.
Okay.
Yes.
So we generally we consider that in initial iterations the individuals explore the search space having the large step size, but sorry, while the in later iterations the individuals explore the search space having the smaller step sizes, and both are beneficial for the solution search process of the individuals.
Thank you, sir. Thank you, sir.
Okay. Clear, Shalendra?
Yes, sir. Thank you, sir. Thank you so much.
If anybody else is having any queries, please welcome.
Ajay sir, please don't mind, but your pic with mic is basically appears like you are speaking through mic.
So it is better for everyone
ऐसा
to
लग रहा है जैसे
speak.
मतलब आप ना माइक के साथ ही बात कर रहे हो मतलब.
हाँ, तो ये अच्छा है ना कि अगर सभी लोग ऐसे रख लें अपना, फिर तो ऐसा लगे कि एक्चुअली मतलब विदाउट वीडियो भी हमारा काम चल जाए और बैंडविड्थ भी बच जाएगी हमारी, है ना. तो विद दिस
शैलेंद्र प्रेजेंट है बस.
हाँ नहीं ठीक है, जो भी अच्छा है क्वेरीज होनी चाहिए, वैसे भी बढ़िया रहता है. तो with this I would like to thank Professor Harish Sharma for this knowledgeable lecture and sparing his valuable time on our request, and thank you all. And the next lecture will start at 3:30 instead of 3. There is a change in the schedule of half an hour, so it will start half an hour late. The next lecture will be 3:30. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Hello, Fateh sir. Hello. Hello, Fateh sir.
હા મને કયો મને બી કાંઈ જ ખા લેવો પડતો ધંધા મુના બુ આવ્યું હતું કાંઈ ભણા